So hello, my name is Sam. I often go by Bats to my co-workers. I'm an animator in the games industry, and I've been, that photo there is from 2016. So as you can see, I haven't changed my clothes in 8 years. I've been working professionally as an animator for those same 8 years, and these are the places that I've worked at. I got my start in A44 Games in 2016, where I worked for 5 years on Ashen and Flintlock. In 2021, I started at Weta Workshop, where I helped out on Tales of the Shire for a while, and got to work with an incredible bunch of people. Many of them are giving talks here today, so please go and support them. That was up until this past July, when I switched back to A44 again to work on some exciting things that I can't share, of course. But hopefully I can come back and tell you all about it when I can. Here's some work of mine. There's some Ashen stuff, some Flintlock stuff. There's a little flippy thing up the top there, just for fun. And aside from animating, I've also participated in NZGDC a bunch of times. So I've given 6 talks here at NZGDC. You'd think I'd have improved by now, or at least sort of like changed the format, but no. All my stuff has been animation focused, and this one's no different. So this is 30 tips in 30 minutes. This might not be what you were initially expecting. I had to do a bit of a last minute change for this talk. But the idea comes from a bunch of the questions that I've had over the past few years. Just frequently asked questions that I've had, and like coupled with the fact that I'm now in my 30s. So I thought it would be good to do a bit of a brain dump and give you a bunch of information that you can use to improve your animation, your process, and your game. So I'm going to go really fast because I've got a lot to cover. But if you want any of this information outside this immediate time pressure, I'll happily share all this stuff with you guys. So first up, what is root motion? So root motion is a source of a ton of confusion for people working in animation. But to put it simply, your animation skeleton has a root bone, and by definition that root bone is the first bone in the hierarchy. So if you move that bone, the motion can be interpreted as root motion, that little red line there. That's root motion. The engine can then interpret that information and move your character based on how the root is animated. The recommendation is that your root bone is positioned like at the origin, and then you structure all of your character around that. So that's root motion, but when do you want to use it? Well, you can use it anywhere really. If you look at the new UE5 animation samples, they've all got root motion baked into their locomotion. It's not used in this case because all of their movement is handled programmatically, but the data is available if you ever need it. But where root motion is more typically used is for animations like these. So these are some animation assets that I've made, and you can see that in each one of these, the character moves forward through space. And we need to move the root with them to ensure that their capsule collision comes along for the ride. So at which point they can start animating from their new end position. Something important to note is that while the character animation is fairly complex, the root motion itself is incredibly simple. Each one only translates the root forward from the start position to the end position. That's it, with the exception of the top right one, where the root has to turn 180 degrees to match the 180 of the character as well. That leads me to my next point. Character spins. I heard a lot of questions about this before. So what happens if I rotate the character 360 degrees? Do I have to rotate them back? The short answer is no. The long answer is probably something to do with quaternions, but we're not here for long answers. What we care about is that the engine solves this for you. In this example, the pelvis bone is rotating, and you can see here that I've visualized the character collision in a second. Boop. And the character is freely rotating inside that without flipping back. One edge case to bear in mind is that if you cancel the animation midway through, you might get an odd transition back depending on how far through the spin you were. So if you're most of the way through, it might continue rotating. If you're kind of too early, you might rotate back. So yeah, something quaternions, but the engine solves that sort of stuff for you. The other case is if you want to turn the character 180 degrees, like that example I had before, in which case you will need to have the root motion animated and turn it 180 degrees and stay there, which is this example here. The major difference here is that the character collision rotates with the root this time and defines a new rotation for the character. This happens because the root bone is rotating. The main difference here is that one is purely visual and the other one actually affects the character transform, so what your player is actually doing. Run, walk, march. So this is a tip about locomotion, specifically looking at this guy, the idle, walk, run blend space, and how we can improve it. So if you've built any locomotion for a game before, you've probably made yourself a blend space where you can sort of put all your locomotion clips in and have them all blend together and get all the in-between speeds. There's one problem with this setup, and that is that the idle isn't really part of locomotion. It doesn't actually move the legs in any way. So blending with that animation isn't ideal. It often results in like some weird blends. So ideally, we should take the idle out of that blend space and move it into its own state. And that's all well and fine, but quickly we run into the problem of now the slowest animation speed we have is just walking. And so that's no good if the player wants to move slowly. So what we need is a locomotion clip for a speed of 0. And what we can do is, to achieve that, is animate a march in place. So that covers our full range of locomotion speeds and will result in a better blend overall at low speeds. By the way, if you want to animate something like that, I'd suggest walking as slow as you're comfortable with and sort of timing your gait to match that for like stepping in place. Start from the down pose. This is a quick one that I saw somewhere and I have done it ever since, and that's for locomotion assets. You want to start from the down pose. That doesn't mean you've got to start animating from the down pose, but you've got to make sure that your clips are exported so they start and loop at the down pose of your locomotion. So that'd be the second pose here. And keep that consistent across your library of locomotion clips. The reason for this is that when the character starts moving, they blend out of the idle, and then they lower their weight and giving you sort of like a mini anticipation for free. It also tends to blend the legs better because it means that at least one leg is planted as you blend into locomotion. Locomotion transitions on a budget. So if you're like me, making transition animations is like the worst thing in the world. And on top of that, there's a lot to refine and get right to make them feel responsive and feel right for your gameplay parameters. And that means your transitions often have to change. One small way around this for locomotion is to increase the play rate of your locomotion assets when you begin moving. This is by no means like accurate at all, but what it means is that when your character first starts moving, they have a few more footsteps when they initially start moving, making them feel a little bit more responsive, and sort of mimics a little bit of how people generally start moving. If they start running, they'll take a few shorter steps before settling into their gait. It's quite subtle. You don't want to make it too extreme, but I hope you can see there that the character was walking a bit more quickly when they started moving. It works well for stops too, because they kind of take a few steps before they stop. Leaning from the hips. So this one is one you might already know, but it bears repeating. We often build lean poses to blend over locomotion, and we do this to get so the character looks like they're leaning into their turn. It's a simple addition to any animation blueprint, animation implementation, and it makes it look great. The important thing is to make sure that leans are built to match the purpose they serve, and it's to maintain a believable balance when they're turning. For that reason, it's important to lean the character from the hips, or more accurately, like the center of mass, which is usually around where the hip control should be. We can take this one step further. Because lean looks great, but it looks a bit robotic if the character doesn't like look in the direction that they're leaning. So we can introduce a twist down the spine. And where was I? We can introduce a twist down the spine so that the character's head will turn in the direction that they're turning. It adds it's also got an additional benefit, which is where it makes your character feel a little bit more responsive to the player's input, because we generally slow down character rotation so it doesn't look overly snappy, but by adding this twist, the character's animation will update to respect the player's input. And we can go one step further with this again, because there's a cool new feature in some of the Unreal Blueprint blend space tools, but this is a new tip because it's a bit different. So blend spaces have this option for smoothing, which you can adjust on a per bone basis, meaning that depending on the value you set, different bones can blend faster. So in this example, the head bone can blend faster than the torso, and then the torso can blend faster than the arm. So you get this nice overlapping effect in a standard blend, which is kind of like utilizing an animator's understanding of overlapping action and lead and follow for your performance. So hopefully you can see the head leads the action a bit more. Strafe locomotion. So Strafe locomotion covers like our full range of like directions that the character can move in, and it's a lot of directions to cover. Typically the approach is to make 4 cardinal directions, so forward, back, left, and right. That's all fine until you notice that things don't sort of blend really well, like the 45-degree angles, and so that's fine. We can add some 45 degrees, but that's more animations. It looks a bit better, but if you test it out some more, you'll notice that there are still some blending issues that happen between the samples. And there's a good reason for this, and it's to do with the fact that if you try and blend a forward locomotion and a backwards locomotion sample, we get sort of like a bit of a mess in the way the feet are animated. Fortunately, there's a way around this, and it's only going to take 6 animations. A good way to approach strafe locomotion is to take 2 blend spaces, one for forward and one for backward, and each one covers 180 degrees of movement. And then they overlap at the left and right directions. The 2 blend spaces can then act like a flip-flop, and as you move, you flip between the forward and the back, but they never actually try and blend the 2. The result is like a system which blends at every angle, and then the flip-flop can be sort of tuned to your liking. So as you can see, kind of like changes direction back and forth. So if direction wasn't enough, we're going to talk about another dimension to locomotion, that's slopes. Not every game does this, and not every game needs it, but if you consider what kind of game you're making, the first consideration might be, does the game have sloped terrain, or is it generally flat? In the case you're working with sloped terrain, an example to consider might be like Genshin Impact versus Breath of the Wild. Those 2 games were largely compared to each other, especially when Genshin first came out, just because of the visuals and the world. But the point of difference between the 2 is that Breath of the Wild takes slope into consideration for how Link moves, and changes the performance based on the slope. On the other hand, Genshin just uses kind of flat locomotion and relies on foot IK to achieve the different slope angles. That example there was made with a single additive pose and control rig, so you can get pretty far with pretty little. Oh, there we go. What was this one say? Blend spaces. So we have speed and we have direction now, and also we have slope, but you might be asking, how do we blend all this together? This is something I picked up working in Unity, where they allow you to make a blend space inside a blend space inside a blend space, so you can get pretty complex with it. Coming back to Unreal, I got to thinking, can you do that in animation blueprints? And the answer is yes. These nodes here, which I've seen very little about online, they're different from the blend space asset that you get in the engine. These are nodes that exist within the animation blueprint itself. But rather than each sample of the blend space containing one animation, each sample can contain its own animation graph. So you can start to blend between much more complex setups. So locomotion is a perfect application for this. So typically you would have a 2D blend space, which would be your speed and then your directions. But with this kind of setup, you can build your way up to like a 4D blend space. So you'd have speed, direction, and 2 slope axes to cover all your different angles. And the nice thing about that is that the character can then respond to the slope that they're standing on with a full body animation that's authored by an animator. Again, this all depends on your scope, but if you're putting a lot of emphasis into locomotion and running around on rolling green hills, then this might be something that you're wanting to look at. Quadruped turns. So quadrupeds are hard, no doubt. There's double the legs, double the gaits, and you have to animate tail as well. The source of this image is from a guy on Twitter called Piotr Beska, and this is to sort of help avoid the school bus effect, where animals kind of turn like a bus. To do this, in the same way that we built leans for bipeds, you can also build turn poses into your quadrupeds. So these poses rotate the torso of the animal to keep them, to show them which way they're turning. I tend to favor rotating the front of the animal so that the front of the body leads the motion. Stabilize the head. So the human body prioritizes like a stable head. Like as you walk around, your head is the most stable part of your body, and our bodies are very good at compensating for the weight distribution as we walk. So our character rigs, on the other hand, don't really work that way by default. So if you rotate the hips a little bit of your controls, the head moves a lot. So I prefer to change the setup so that the stability of the head is prioritized and the rig compensates for me. The way to do this is to have the head aimed at a point that's floating above the head. The result is that when you move the hips, they automatically rotate and keep the head more stable. I should say there's a lot of resources online for this workflow. And you can aim anything to from the head or like an arm, so you can stabilize and clean up a whole bunch of work that would otherwise be really difficult with rotations. Looking with the head and neck. So this one is for connectedness of the body. In particular, this applies to head look, which might be used at runtime. So if a character looks at a point of interest, there's a temptation to just rotate the head, which looks a little bit robotic. So it's really important to make sure that the neck is involved and like have that responsibility shared by the head and the neck as you to achieve a more natural head look. When to set keyframes. So this one sounds like a simple one, but sometimes you get a bit lost in the sauce with your keys and you want to organize yourself a bit more. So one piece of advice is to key essential changes. So, there we go. By essential changes, I mean like the things, like the important moments, like when the foot touches the ground, when the hips are at their lowest position, or the peak of a jump. This goes back to like the traditional keyframe, key animation process from like traditional animation. These moments are like the structure of your animation and applies to the early stages of like, block out and stuff. But the intention is to keep your keys sparse and a bit more lean so you don't get overwhelmed with a lot of different keyframes. Virtual bone space switching. So if you've come to any of my talks before, you might have heard me talk about this, but it's my favorite thing. So one thing to pay attention to here is, when it plays. Uh-oh. There we go. One thing to pay attention to here is the little coffee pot over on the left-hand side. When she gets up, you'll notice that it jitters a whole lot. And this issue occurs because while the coffee pot is trying to stay stable over here on the table, it's actually parented to this hand the entire time, which is moving around a whole bunch as she's animating. And this happens because the animation was authored at 30 FPS, but as we know, games run at like 60 FPS or higher, and so anything that's not set on a whole key within the engine is considered a subframe, and that can get a bit like the math behind the subframes can get a bit messy. And so if we watch this again, and spoilers, it's going to be perfectly stable. With virtual bones inside the engine, you can change the hierarchy of the skeleton and bypass the fast-moving parts of the body, and the result is like a much more stable performance, because now, while it has the same animation, the coffee pot is actually parented to a completely different bone that was created inside the engine. Increased gravity on the way down. So this is a simple one that makes a huge difference. It applies to a character's jump. There's a really good GDC talk about this already, which covers this topic in a lot of nuanced detail, and I'd really recommend checking it out. But if you have a jump in your game, it's going to be important to get it right, because one of those actions that the player performs a lot. And one sort of surefire way to improve it is to increase the gravity after reaching the apex of the jump. So you can experiment with different settings, but I would say at least double it. It really helps with like that floaty feeling, especially the one you get in like the default jump in Unreal. It makes the character feel a lot weightier, and it sort of weirdly makes it feel more controlled for the player. So spend time with those settings, because a jump is one of those things that you do heaps. Predicting your landing. So getting the feel right of a jump is important, but also getting the landing to work nicely is another challenge in itself. So most landing animations are made to be reactive, so they happen as soon as the character collides with the ground. It's not a problem, it's snappy and responsive, but it sort of feels like the character's not really aware of their environment, and they're kind of like reacting to things that have just happened around them, and so it feels a little bit less believable. It's kind of hard to tell in this example, but we can make a predictive landing pretty easily by raycasting in the direction of our velocity, so we can find where the ground is as the character's falling. So from there, you kind of see like the little valley up the top there. From there, we can get the distance to the ground and then extend the character's feet or do something like that to as they get closer to the ground. So suddenly we've gone from being reactive to the environment to being aware of it. And it makes our character feel more believable. Additive animation versus layered animation. So quickly to explain the difference, additive animation is what it says. It adds one animation to another. For example, the lean on top of the locomotion before, that's an example of additive animation, where the character was made to look as if it was turning in a direction. Compared to additive animation, you can think of layered animation a bit like a mask. So you can mask out certain bones of your character and have those bones play a completely different animation. 10 minutes, okay. So this is better suited for having things like your character like hold objects. I generally like to think of layered animation for when a character needs to do two things at once, like walk around and carry an object, whereas additive animation is good for modifying what the character is already doing, like the run into a turn. Mesh space versus local space additive. This is one of those ones that always comes up on like the Unreal forums. It was kind of struggled to visualize how this looks, but I've opted to show this with a crouch animation. So this is the crouch asset, and it's just and we have two ways of applying it. We have mesh space or local space. So if we apply it in local space, the crouch animation is added to the local rotation of the bones of your character. So this means that the orientation of the bone affects the way that the additive is solved. So if we notice that in this case, the legs become unstable in like a weird way, this is because the bone orientation is changing as the character is walking. So compare that to the mesh space version, and you can see the legs are much more stable. This is because mesh space causes rotations to solve in the root space of the character, so it's always going to be the same orientation regardless of what the parent bones are doing. So it makes it perfect for additives which need to rotate the bones in a more deterministic way. It's also a really good use case for head look, when you need to have the character look in a very specific direction. Skeleton LODs. It's always a good idea to build LODs for your skeleton meshes. You don't need all those fingers when your character's like 10 pixels on screen. So you can make these by hand, or there are some really clever tools in the engine which can handle generation of LODs for you. It's just, yeah, it's really robust and works really well. Does that go through some examples? Yeah. Next one. Metrics. So it's really important for the animation team to be involved in metrics, particularly working with the design team or level design team. If you're animating, it's important to know the metrics of your game. Like how fast does the character move, how high can they jump, how steep of a slope can they traverse, but also what an animator can provide is a way to visualize those different metrics. So it's really valuable for prototyping and making decisions if you can sort of like see the feedback. Tangentially, I've also noticed that people who work in animation often have a pretty intuitive idea of what these metrics should be, just because they spend so much time working with how fast people should move, how high they can jump, things like that. So get involved with that, because I think people would appreciate your insight if you're into animation. This is a little known option in Maya that I really love. There are fall-off settings for your graph editor, which is great for moving a large set of keys. I bet there's like a bunch of like plugins that you can get for this, but I like to just use standard Maya stuff because I'm boring. And yeah, I still use the classic graph editor because it's the best. But it allows you to move your keys in a non-standard way, which is really, really helpful when moving like dense data. And yeah. So less nodes. So if you've used Unreal, you understand like the spaghetti of blueprints, especially if you're a programmer and you kind of hate what designers create. This is a quick one for Unreal 5 users. You can now directly bind variables to your nodes in your anim graph, which is really, really useful. So you can see that my lean blend space doesn't actually have a pin input to it, but I've bound it to the output of a function. So less nodes, less noodles is just a lot tidier. Breaking your hierarchy. So animation rigs are built in a hierarchy of controls. Each child is influenced by its parent, but sometimes when you're working, you want to just change one control without influencing the child objects. So by breaking the hierarchy with something like a parent constraint, you can selectively manipulate certain controls without influencing the others. So this can be very beneficial when you're polishing or just achieving some functionality that your rig might not necessarily provide. So I think you can see, I just want to move the chest but not the head, and now I can move the whole chest around and the head stays stable. Speaking of rigs, things your rig doesn't provide, pivots is another one. Pivot points are found at each control of the rig. And pivot points are generally at the center of the control object, and that's just the interface you get. In this example, it's the foot control. Usually the pivot for the foot is located at the ankle, but in reality the ankle never actually makes contact with the ground, and most of the time the foot needs to pivot around the ball of the foot. Some rigs come with extra controls to address this, but I kind of hate using those, so I would much rather create a quick setup to make a new pivot at the ball of the foot and bake it down and move on. So rather than having all these different attributes, I just manipulate one set of rotations. Much, much easier. Oh yeah, so I was already running out of ideas after like tip 20, so here's my cat. This is Alfred. He's very spoiled. He has an automatic feeder, a running fountain, and Hill's science diet. He's got the works. He's a good boy, and he's a good distraction from work, which leads me on to my next point. Have a hobby. It's hard to create the illusion of life without having a life, so particularly in this line of work, which is so hyper-focused and detail-oriented, having a hobby gives you a good break and gives you more details to add to your sort of, library of things in your head. So my hobby is baking sourdough bread. So I bake sourdough like 3 or 4 times a week. It's a nice break from the computer. I also collect vintage pottery, which is I've hit my 30s hobby. So if you want to chat afterwards, you don't know what to talk about, we can talk about bread. Speaking of having a life, use reference. It's invaluable to use reference. And like I mentioned before, being detail-oriented, it's a great way to find all those details in your performance. Here's me doing some reference for the production of Flintlock. I very much recommend finding some props if you can. It really helps with the weight. We've got some foam weapons at A44 that we use. They're like LARPing props, and we have that kick pad thing for a shield. But you can make do with some stuff at home. We certainly had to during lockdown, so here's me rocking my paint roller and some slippers. It's a lot less fun doing it at home. As well as using reference, I would highly recommend shooting it yourself if you can, especially if you're in a team. This is for a couple of reasons. First is that it's really great team bonding. Oh, is it 4 minutes? Cool. It's great team bonding. The most fun I had at work was shooting reference with Adam and Scott during the Flintlock production. Because there were 3 of us, there was 1 person holding the camera and 1 person in the background adding some flavor. It's really embarrassing at first, and it feels pretty Gumby, but it doesn't need to be perfect so long as, oh, my bad. It doesn't need to be perfect, but as long as you get the, no, stop playing. Oh. There we go. So long as you get the intentions of your idea out, it's useful, and it's really good for early iteration because you can get a bunch of ideas out in a visual format before you even set a key. And yeah, with your friends, it's just a good time. I've kept all the reference footage from our shoots because they're good memories. Yeah. And spoilers, yes, that's all 30. So I don't know if we even have time for questions, but if anyone does have questions, I'm happy to take some. Yeah. You can, and you don't need to either. So you can kind of just, like, the 360 would solve itself. Like, it would turn back to normal and just carry on as usual. So you don't need to rotate them back. Yeah. Anyone else? Oh, another one? Yeah. Mantling. The newest game animation sample pack from Epic has some really good examples of mantling. The one thing that they do, which is a really good idea, I think, is they have a separate bone in the character rig, which is entirely to determine where the character is trying to get to. So you have a reference in your animation sequence of where the character is at all times and where the character is trying to be. So that's a really useful way to know like where your character is going to end up. But it also means that you can then use that position as a way to warp if you need to, solve for any, because nothing's going to be perfect. You need to solve for any slight variance in your mantling animation. So the warping functionality that they have, on top of the fact that they provide a position to move to, is a really good approach, I think. Yeah.
You mentioned how when you're jumping, the gravity's half going up and double going, same going up.
You're saying going up, yeah.
Is there more examples of things which are fundamentally wrong but feel right?
I think just character speed in general is one, but yeah, I don't know. Gravity's the big one, I think. I can't really think of any others off the top of my head, but like if you think about how fast a character actually moves in a game, it's way, way faster than people move in real life. So that's another one that's kind of like, if people were moving at like an accurate speed, you'd be like, oh, this feels terribly slow. Yeah. If not, it's cool.
Yeah. I'm not an animator. This might be obvious. But so when you record reference for animation, is it like quite good to usually record them from different angle as well, or usually you can just work based off one angle?
Yeah, we did do some where we had one person standing in front and one person on the side, and we filmed them at the same time. It just became a bit tedious to try and line them up afterwards when we were trying to, we pull them into Maya and we sort of like retime things to have it in the scene next to our animated characters. It just sort of became a bit of a pain to match the two, and so we opted to just most of the time just do one angle. But yeah, certainly have done that. Yeah. Okay, I had a couple more things. Before I close off, I gave a talk a couple of years ago about this character, which we saw earlier. That talk wasn't recorded, but I've just made all of these slides, including the speaker notes, available online, and it's on my Twitter. And also we're hiring, so we have a couple of applications open for a technical animator and a principal concept and UI artist, and then general inquiries over here. So if you like what you heard in this talk, you might be a technical animator, so please get in touch and yeah, come ask any questions. And I'll just go to the last one. That's all I have. I hope it's been a good session for you and you've learned a thing or 30. Thank you.